Hey, good morning. If you're watching this live, it's my phone's still buzzing. It's 11. It's 1 minus. It's like 10:59, but I didn't really care that much. Because I'm tired and I had to take a nap already. By golly. Today we're doing our very last lesson. Next week I'm gonna give you a review, and the week after that we're gonna give you a quiz, and that's the end. Like, that's school. Isn't that crazy? Now, I say this on Friday, and I'm dropping this lesson officially on Monday, but it really is the last lesson, and that is really crazy to me. So, today we're going to do, a lot of people think this is the hardest lesson, and they think it's the hardest lesson because it takes so many steps, but the steps are, you already know all the steps, okay? That's the good news, because, and I'll tell you this again in a second, but the steps are, Maya, my only person watching is an Algebra 2 kid. Maya, hang out. It's great. Thank you for not swearing at me. So you already know that when you solve systems of equations, back from, what chapter was that? 3? No, 5. Back in chapter 5, we solved systems that had the weird squiggle on it, and you had to plug things in or make them equal to each other. That was substitution elimination, technically graphing too. And we had to find the one point where they both agreed. Now here's the tricky part about this one. Oh, I mixed them up, that's okay. Okay, for these, I have maybe a straight line, maybe 2 quadratics, but usually it's a straight line, and a quadratic. So, these two could intersect twice. They're usually a really nice number, like this one. So this one intersects here at 1,6 and here at -3,2. That's the part that people get frustrated by, is that I'm looking for 2 answers with an x and a y for both. And it's not like it's positive and negative, because this line could be slanted, or it could go this way, or it could be flat, or it could go straight up and down. It doesn't usually do that though. But it also could hit only one time, right here, like -1, -4. And it could technically hit no times. Anywhere down here is no times, right? So once, twice, or not at all. Those are my 3 options. We've had the quadratic do the same thing. Oh, can I change that real quick? It's going to confuse you maybe that they're both going to be moving at the same time, but so just the red line has no solution here. It has one solution kind of in the middle of these two, and then it has 2 solutions all the way down here. So those are the options for when I only have 1 graph, and when I have 2, it's the same. Once, twice, or not at all. Okay? So that's what we're doing today, is we're finding those solutions. Now, can you go to desmos.com, plug in the 2 equations, don't use b, use the actual numbers, and see where they intersect? Absolutely. This is actually the problem that we're doing today. Not exactly this problem, but it's fine. So I'll show you what the answers are to that. Is that not the problem? Oh yeah, because I changed b to be the same in both. So can you go to Desmos, plug them in, and find the answers by kind of rolling your mouse over or clicking on the line? It'll tell you. It'll tell you where it intersects. I have no problem with that. In class on a test, like in a classroom on a test, you can't use the Chromebooks. At home on a test, how am I supposed to know? This is a bonus knowledge for those of you who actually watch my notes, because not all of you do. Maya knows the secret now, because she's watching the notes. It's all good. Okay, so what we're going to do today is I'm going to do 2 problems on here. I'm going to pause and show you the homework, and then I'm going to do 2 more. I might even go kind of rogue and show you the homework in the middle of the first problem. I don't know yet. Alright, so let's do some problems. I'm going to have to move that one. Okay, that was distracting me. My Desmos was still open on my screen up here, and I want to see how many viewers I have. I'm using blue and yellow just for the heck of it. This is 9.6 nonlinear systems. I'm on page 54, if that still means anything to anybody. I like to keep it real like this, so if you need to pause it, 'cause it's going to go out of the screen soon. Let's just start. Usually I write things down, but I think that was my thing that I would write down normally. Remember this little swoop thing that kind of looks like a face? Don't worry about it. If you can do it, you can do it. If you can't, just make a little box. I do kind of like watching your attempts, though, and my attempts are not. Like, these are so different, but it's fine. Also, I was blessed with 2 different cat pictures attached to homework this week. So if anybody wants to just throw in a cat picture on top of their homework, it made me so happy. One of my, I bragged about it on Facebook. Somebody was like, extra credit. I was like, can't do that, but I know some people give extra credit for cool pants sometimes, so who knows what I can do in my own classroom. But I recorded on YouTube, so now I can't. Okay, so here's what we're going to do. We're going to take, see how both of these equal to y? It's y equals 2x squared minus, or plus 5x minus 1, and y equals x minus 3. Those are my 2 numbers, variables. I don't know what it's called. And this is going to be true for all of them. Oh, I should have highlighted first. What I'm going to do is I'm going to take this entire equation right here. Ew. And I'm going to set it equal to this little baby equation right here. I'm going to make them equal. Because if they both equal a y, then they have to equal each other. That's just a rule. And you'll actually learn that next year in geometry too, because they talk about, oh, I should not be doing this. Reflexive's wrong. It's fine. I'll figure it out. So many pictures of cats. No, it really made me so happy to grade when I ended up with cat pictures. 1. Make the 2 equations equal. Now, this only technically works if they both equal y, but spoiler alert, they're all going to equal y on your homework, so I don't care. And then we solve for x. Oops. Why does that look like that? For x. And that's only step 2. Don't get too crazy, but we have some methods to solve for x. We can complete the square. We can use quadratic formula. We can factor. And on rare occasions, we can use square root method. Remember, for square root method, though, I have to not have a b anymore. And so we have to have an equation where the b's will cancel. Alright, so let's do it. I should have grabbed a pen. And I should have told you what color I chose. Purple. You're welcome. Alright, so I want to move everything to the side with the x squared. Unless the x squared is negative, which I don't think it's going to be. We're just going to do that. So I'm going to subtract x from the 5x, and I'm going to add 3 to the 1. Because that'll cancel out both the things on one side and move them over to the other. So I get 2x squared plus 4x plus 2 equals 0. Now, this looks a lot like a quadratic formula problem because of the 2 in front of the x squared. But I'm going to tell you a secret that you'll only need to use on this problem, but I might as well tell you a secret anyways. These are all divisible by 2, and because it's 0 over here, good, I'm glad, Maya, I can divide every single part by 2 to simplify it before I keep going. This is kind of like a bonus step, and it's just because it equals 0. I couldn't have done it up here because I had odd, 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 but when they go together, they become even. So I get x squared plus 2x plus 1 equals 0. Now, my personal favorite method is factoring. If we were in class together, I would ask you which method you wanted me to do, but I just want to factor it because I just kind of feel like it, you know? So I'm going to factor this by doing 1 on top and 2 on bottom, and then 1 times 1 makes 1 and 1 plus 1 makes 2. So that's pretty simple there. So it's really an x plus 1 x plus 1 equals 0. And because they're the same number, I don't need to solve it twice. I only need to solve it one time. So I have x plus 1 equals 0. It's the same for this problem. If they were different, I would solve them separately, but they're the same. And then I subtract 1, because that's zero product property. X equals negative 1. Okay. Now here's the trick that people forget. You know how I was in Desmos and I was showing you how that worked? This answer is a point. Oh, this answer is a point. It's not just negative 1. It's negative 1. In this case, it's 1, negative 1, negative 2. Don't let that confuse you. It's going to be different. Because remember, I changed this. Because it's a negative 1. And this one's a minus 3. So it's actually negative 1, negative 4. So I need both parts. So my second step is to solve for y. Okay. Now what I always do is I pick the easiest equation to use. I'm going to do the Dora the Explorer thing. Would you rather use this equation or this equation? That's right. We should use this equation. And the only reason I can do that with confidence is because very few people say that the thing with the squared looks easier than the thing without the squared. Have you ever watched, I don't know, like Sunday morning cartoons and Dora's on and she's talking to you, but you don't feel like talking back to her because, I don't know, she just you don't feel like it. It's morning. I'm plugging in the negative 1. In class, somebody's going to ask me 3 times where that negative 1 came from. I'm using the blue equation with negative 1 plugged in. If I had 2 answers here, I would have a second equation also with whatever number it is plugged in. I'll show you that next. But just for now, all I did was I took the negative 1, I plugged it into the blue equation. And that's negative 4. So then my answer is x, y, negative 1, negative 4. So remember, it's always x, y whenever we do a point. So I'm going to put it into an ordered pair. Which is a really fancy name for this. We don't really need to worry about that. Okay, for those of you who were just runners and you want to just get for this, here's your homework. There's only 5 questions. They take a little bit. If you find yourself taking more than like an hour total, including my lesson and these, just stop doing them. It's more for practice than for anything else. Also, this one, I would move the x squared and stuff over to the other side than the other way because it's a negative x squared. You want positives. Same with this one. That one you can probably divide like we did. I don't know. It might also be a quadratic formula problem. 3x squared minus 3x. No, that's divide by 3. You're good. So I'm glad I showed you the trick. All right. You're good if you want to go, but I'm going to keep going. So, welcome back. Also, if you get stuck, you can always come back to this point. I'm going to do one more, and this one more has 2 solutions. It looks like, I need the B back. Oh, shoot. I almost swore too. It'll look like one of these where it has a solution here and a solution here, but unlike this one, it'll be nice numbers like this and this. Because we're really nice to you in Algebra 1. I don't do this to my Algebra 2 kids. I give them really hard problems. Alright. So here's my other example. We want to solve. I'm gonna remember this time. Okay, that one's kind of long, and this one's another short one. Okay, let's see if that worked. It's rude that I give you problems that don't have nice numbers. I am so sorry. Also, I'm teaching you from home and you're learning from home, and I'm not there to help you when it looks scary, so I don't know. I know. I think you meant also, but we could talk about ASL because I've been learning that. It is much shorter. It's been 15 minutes right now, and I'm doing 2 problems. But I don't know, I might do more practice problems because I just know that some kids need more support. Shout out. But it's all good. Alright, once again, I'm going to make the 2 equations equal to each other. So I'm going to make the yellow one equal to the blue one, or whatever colors you used. Plus, of course we picked the hardest freaking unit to just cold teach you from home. Like, in Algebra 2, I mean. Because I'm teaching them graphing squiggly lines, which is not something we've ever done before in math. In math we do it, but not in Algebra 2. So it's like, hey, here's this brand new concept that you've never seen before. Oh my god. Alright, I'm going to move everything this way. So, yeah, and then it's weird answers. It's like root 2 over 2 and 0.7 of 7, which is exactly the same, by the way. That's how I used to remember how to do it. Alright, so I get x squared plus 3x minus 4 equals 0. Let me try factoring just in case it works. I can't complete the square on this one because it's an even middle number. I could probably quadratic formula, but it seems the hardest, so I'm just going to try factoring really quick. So I want negative 4 and 3. 4 and 1 make 4. And if the 1 was negative, it would be a positive 3. So this is actually x plus 4, x minus 1 equals 0. Please don't stop here and say the answers are 4 and negative 1. We should know by now that it's opposites of those numbers. Because I'm going to make zero product property, x plus 4 equals 0, and x minus 1 equals 0. So when I solve those, I'll show you the steps. When I solve those, I just like to do them both at the same time as I have my pen out, but you can do them separately if you want. X equals negative 4, and x equals positive 1. Could I have gone straight from here to here and just known that it's opposites? Absolutely. But I know if I do that on a live stream, somebody's going to get mad at me, so I might as well just do it right. Okay, now I have 2 x values, which means I have 2 points. So like I have this one and this one, right? These are 2 different x values. This is not the graph, so don't worry about it. I'm just giving you an example of something with 2 answers. I need a y value for both. Notice that this one's a negative 3y value, and this one's a negative 1y value, so I can't like cheat and assume that they're opposites or anything like that. That'd be pretty cool, but it's not going to happen. So I'm going to take and make these both into y equation using the blue one. So I'm going to take y equals negative 2 times negative 4 plus 3, and y equals negative 2 times 1 plus 3. So I make 2 different equations because I have 2 different x values. One y value for each x value. This one's going to have 2 answers. Okay, that's fine. It's going to be 4 numbers, but they're going to be in 2 to answer sets like this. This is 1 answer. Sorry, not sorry. Okay, so I have y equals, this is 8 plus 3, so that's 13. And then this one's y equals negative 2. I don't know why I winked, I'm sorry. Y equals negative 2 plus 3, which is 1. And then the next part that is hard for some people but not hard for others is that I have to remember that like this one went with this one, sorry, this one went with this one, and this one goes with this one. Because if I mix those up, then it's opposite, it's a different problem. So, and I might try to trick you on that on your quiz. Negative 4 goes with 13, and 1 goes with 1. So those are my 2 solutions for my system of quadratics, or system of nonlinear equations, which is also kind of a lie because there are linear equations involved, but meh. Alright. What do you think, Maya? Should I do 2 more examples? Or should I just call it good here? You tell me. You're in charge of your own fate. That's not your fate because it's everybody's in Algebra 1. You have everything you need. You know all the stuff. And I mean that overall, not just to Maya. They're just hanging out with me. Because I didn't record a lesson for her class because it's a... Thank you. That doesn't answer my question. Should I do 2? I have 2 more examples on here. I can do them. I didn't do a recording for Maya's class because they're not doing any new learning next week. It's review time. It's so exciting. So that's the 2 answers. I'm going to color code the blue. I'm going to color code when I plugged it into the blue equation. Yuck. I didn't know that would still smear. Okay. Thank you for clarifying. If you, I'm going to throw you under the bus just a little bit, Maya. If you disagree with Maya and think I do need to do the other ones, please message me. Please let me know. I will. But I think she's right. Should I? I'm going to stop coloring. It's pretty fun, but... Okay. That's the end then. Have you guys... Oh. Nope. I'm doing it wrong because I'm in a different mode, and I shouldn't have done that. It was distracting to have 2 of me, TBH. Okay, so right now we are here. We're at the very last lesson. I'm going to give you a review next week, and then, not next week, today's Friday, so on Monday, we're dropping this lesson. The week after, which is on the 8th of June, I'm dropping your review. And then, honestly, whenever you're done with your review, you can ask me for your quiz. I just want you to have it, have the review done before that, you know? Same kind of thing for Maya's class. They're doing a review, and then the quiz, I think. I'll decide later. I might just do a review, and then the quiz, and then have a free week where I give you, like a quiz, information's the wrong word. I'm done now. Okay. Hey, you guys and gals and people without gender, I hope you have a beautiful day. Enjoy whatever day you watch this. If it's night, enjoy your night. If you do work better at midnight, you do work better at midnight. I'm not going to judge you. I do work best at like 3 a.m. No. I do work best at like 7 a.m. or so. I don't do work well after that. So, have a great day. This is my last video for you. After this, we're doing review and then done. We should have like a group chat or something, though, for the end. Alright. Have a great day. Bye!